Welcome to PTC Express Video Tip of the Month. My name is Leo Green. Tubular weld-up or tubular weld-up construction is really very common in industry. And of course there's many different techniques associated with the design and development of tubular structures. Today I'll be discussing a number of techniques that I found to be very useful in the development of tubular structures. This is a go-kart design that I was a part of some couple of years ago. And again, many different tubes, each of which need to be defined on their own, as well as a fish mouth kind of detail on the end of each one so that it fits appropriately with the one adjacent so that they can be welded appropriately. Let's talk about a number of different ways to make this happen. First of all, as with most assemblies, I'm going to recommend a top-down approach using a skeleton. So true to form, this assembly has a skeleton associated with it as well. And if I were to open that skeleton, you'll see that it is a number of curves associated with each other, broken into individual features, with a design intent established for each one. They all can move appropriately and with respect to each other in an intelligent fashion. You'll notice here conspicuously missing, though, is a lot of the rounds and fillets and bend radii. To me, that's more of a part level detail, and so I'm going to recommend that you keep your skeleton actually very simple. Okay, so let's show that skeleton in the context of the assembly. On the layer, I'll unhide the skeleton's layer. Let's look at just one of these parts in particular. I'm going to single out that guy. There he is here. So you'll see the part starts, got a copy geom, and that grabs a couple of curves from the appropriate skeleton. You notice that the curve that defines its overall length and position, as well as the adjacent curves, are the ones that are copied in here. I'm going to open this part, and we'll build this part again. So I'm going to remove all the features that are in it. So if I pick the copied feature and then move the mouse, then I can pick an individual curve and I'll jump straight to sweep here. And if I right click, you'll notice that sketch is missing. Why? Because it doesn't know what the X vector is. So I'll pick this plane to help it decide or define the X vector for the sketch. So now I can go straight to the sketch, right click, I'm going to throw in a quick circle. Most tubular construction has a number of defined tubes. In this case, we're going to use 1-inch tube as well as some 1 1/4. So the sketch is really very simple, and there's our swept circle. But let's say I want to make it, this is a surface, let's say I want to make it solid. So now it's a solid bar, but I also know that it's a thin wall, so I'm going to specify a thickness. Let's just call it 0.60 for this case. So we have a 1-inch tube, 0.60. Now here's the tube, and it is of the correct length. However, it goes all the way from the intersect of one to the other, which is really a little bit too long, as well as the notches are missing. Well, if you know you've got a lot of notching to do, I'm going to recommend that you use a user-defined feature. So I'm going to insert a user-defined feature. I'll touch on this a little bit today. Now I've created a couple of user-defined features. In this case, I'm just going to use the 1x1 notch. And I'm just going to middle mouse through here. Now, pulls up a dialog. This text is determined by me when I created the user-defined feature. So I'm going to select the tube curve, and then the second reference I'm going to select is the notch curve. And we call that done. So what actually happened here? You notice we have a very nice fish mouth associated. Well, I'm going to break this group apart so you can see what's in there. Ungroup. So you can see here that that group threw into my model a number of features. So one is a plane of the two curves selected. Another is a plane through the tube curve normal to the first created. The third feature is a sketch. Now this one is really kind of interesting. So let me kind of focus in on that real quick. What this sketch does is it identifies how long the tube needs to be. That's with this line. How far back it needs to go so that I don't have too much of the sharp point but enough of it to make my weld appropriate. And it all compensates with respect to the angle of the cut. And then when I throw it on the drawing, I have this edge, this curve here, that I can dimension to the overall length of the tube as cut, the full length. I then have a pair of curves here that I can put an angle on to show the angle of the notch, and then the notch itself, which is done with the extrude to cut the end to the appropriate length. So it's actually a little bit shorter than the swept length was, and then I have another variable section sweep that runs along this guy to actually throw the notch in. So all that happens really very quick and very consistently. Let me just show you another application of that same one, and you'll see some of the eventualities that you may run into. So we'll insert, user defined feature, the 1x1 notch, middle mouse, tube curve, notch curve. Now you notice this time it threw it up on the outside of my model. So with the adjustments pane, I can specify flip angles. And that's what was necessary in this case. And now I have a second notch. And if I go back to my assembly, there it is, thrown in. Now at this end, it needs to notch to the 125. So watch this. Open the part, come back over here. I want to edit this group, and the cross is a 125. Control G to regenerate, and you see this is a case where I can actually shorten this up a little bit. There we go. Very nice. And so if I go back to my assembly now, there it is. Perfect for welding. Let's look at another one. You might have seen real quick that I showed this part. Let's go and open that one so you can see how that one comes together. This one's a little bit different because the copy jom is angular. It's not in any one particular plane and so on. So how has this one come together? A couple of axes, a couple of planes, and then there's something there called a pipe. So let me throw in a pipe so you can see how that works. Insert, and on the advanced dialog there's something there called pipe, where you can specify geometry, no geometry, hollow and solid, constant or multiple radiuses. I'll just choose the defaults in this case, where the outside diameter is going to be 1 inch, the wall thickness is 0.60. And then I'm just going to pick a starting point, a second point, and when I get to the third it's going to ask me about a radius. I'll use the 2 inches here, and then I can pick another point and I can continue to go, or I can middle mouse to call this done. And there's my pipe. Really very, very nice. And if I right click to edit this, I can modify the outside diameter, the wall thickness, and the radiuses. Very nice. So in this case, that's how this one was created. I'll take that pipe out and put the rest in. So then we have the pipe. We have another user-defined notch that you just can throw in on the end. And in this case, we took advantage of the notion that the other side is identical. Well, I hope a little of this made sense to you as we covered a couple of tips associated with the design and development of tubular construction. My name is Leo Green. Thanks for watching.